Routing and Switching, Chapter 7, Packet Tracer 7.2.1.6. We're going to configure a numbered standard IPv4 access control list. We have a topology in front of us, and we want to try and understand what the rules are for this. So as a brief overview, we want to stop our 11 network from getting to our web server, but we want to allow our 10 network and our 30 network to get up and view the web files. And the second scenario is we want to stop our 10 network from getting into our 30 network. So we'll need to consider where we place these. And because they're a standard access list, the standard access list is as close to the destination as possible. So for us, that'll be this interface in an outbound direction for our first rule of denying 11, and it'll be this interface outbound for our second rule, deny 10 getting into 30. So let's get on to our first router. Have a quick look at our router with no setup on it. We're going to have a quick look at how we want to write our access list. And we want to deny our 11, which this wildcard will do, which means it'll check that it's a 192.168.11 and ignore any of the hosts on that network. But it has to match to 11. So if this number was 10 or 30, that won't match, therefore it'll be allowed, or it won't be denied. Because the second part of that access list is permit any. Now you'd need to put this in because there's an implicit deny all at the end, which means we would deny our 10s and 30s by default. So we have to allow those through. So let's see if we can configure our router up. Access list 1, and our choices are for a standard 1 to 99, because if we typed in 100, that would be an extended, and that would look for source, destination. It would also look for the protocol and other rules inside that. We're going to deny our 11 network, and our wildcard mask is the inverse of our subnet. So why our subnet mask would look like this, we want to invert that. And then what we want to do is permit. Now we could just permit our 10 and our 30 networks, and that would be quite a strong level of security for this network. But if you have to expand your network, then you've got to go and edit this out. So for us, we're just going to give a any, and that will cover those 10 and 30 off, because at the end you have a access list deny any, and it's called implicit, so you don't even have to write it down, but it would look like this. Now we want to apply our access list, and we do that using what's called an access group. And we worked out that we want to have it on our gig interface, And our gig interface that's been set up was our gig 00, and we want to apply it out. So you have to type in IP, and what that really means is it's IPv4. If it's going to do an IPv6, you'd add the 6 in. For us, it's IP. Now, we needed to move on to the interface before we did that. It changes it from being an access list to an access group. And the access group has to match the list. So we can't put 2 in there because that doesn't match the number that we put for our access list. And we're going to type in out. Now, the in and out directions are probably the most confusing part of any access list. And the reason is this. If we go and look at the way that you apply this on an interface, here's our interface here, and quite often you think that the data is coming into the network or into the LAN. But that's not that accurate, because it's not about where the LAN is or the network and from the point of view of the traffic flow. It's about the interface and how it's moving to and from that. So for us, that's not an in, it's moving out of that interface. So always think of access control lists as interface-based, not from network traffic and not going in and out of the LAN segment. So we can try and check if that works. We'll just check our config. And there's our access list applied to the interface as an outbound, as a group. And here are the rules. It's stopping our 11s and allowing everyone else. And this server is 254 as a 20. So let's see if we can ping it. And it's unreachable. And if you can't ping it, obviously you can't browse it, which is the whole point of a web server. And let's see if our other networks are able to get to that same device. And then PC1 can. And our PC3 can. Now at the moment, our PC1s can get into the 30 network. PC1 and PC3 can connect. Now the next rule that they're trying to apply, or that is given to us, is saying that they're going to stop PC10, network 10 to get to network 30. So it's the same logic of we want to apply this as close to the destination as we can. So we're going to apply it to this gig interface here, and it's going out of the interface. It's going into the LAN but out of the interface. And this is a numbered access list. Now, because this is on a different router, you can reuse that number. And we want to deny. In network, and the mask will have to read the whole network. The first 0 is checking that the number is going to be 192. The second 0 is checking that the number is going to be 168. And the third 0 is going to be checking that number is 10. So if you were to write that out as a dot decimal in bit patterns, these would actually be 8 zeros. So the 0 is just counting the fact that they're all 8. When you start to subnet is when you start to change these numbers. And we're going to ignore the hosts there. And what we want to do is get rid of our deny any at the all at the end. And we're going to permit any. And that'll allow our 11 network to get to our 30. Now we need to apply this. So we've applied it to our gig 0 going out. And let's see if we can ping between these two now. So we'll use the same command that was allowed previously. Now it's denied. And we're going to try and ping from our 11 network to our 30, and they're allowed. So we've satisfied all the criteria.